You look up at a clear, starry night and you just wonder, where did all of this come from? It's a question we've all asked, right? Maybe since we were kids singing Twinkle, Twinkle, Little Star. Well, today, we're actually going to try and answer that. We're going to tell that story, the story of literally everything. So yeah, let's just get right to it. Where did it all come from? I mean, everything, from the smallest speck of dust on your bookshelf to the galaxies billions of light years away. What's the origin story of our universe, our home planet, and, well, us? All right, let's dive in. Okay, so our story has to start at the very beginning. I'm talking before there were stars, before there were planets, before there was anything you or I would even recognize. We're going back to the creation of space and time themselves. Now, our best scientific explanation for how this all kicked off is the Big Bang Theory. And no, not just the TV show. It's this incredible idea, backed up by evidence from people like astronomer Edwin Hubble, that our entire universe started from a single point and has been expanding ever since. So let's try to wrap our heads around this first moment. Imagine everything, every star, every planet, you, me, all of it, crushed into a point so tiny, so hot, and so dense, it's basically impossible to imagine. And then, bam, a massive, violent expansion kicks off. And get this, within just the first few minutes, as things started to cool down a tiny bit, the very first atoms, the basic building blocks of matter, started to pop into existence. So when did this all go down? Well, the science tells us it was a staggering 13.7 billion years ago. That's how old our universe is. It's just wild to think about. This visual really helps get the idea across. You've got this one single point, a singularity, and then space itself just starts stretching. It expands outwards, taking all that new matter and energy along for the ride. And here's the really cool part. It's not over. This expansion is still happening right now. Galaxies are all moving away from each other as the universe keeps on getting bigger. All right, so the universe is born. But at this point, it's pretty much just a giant expanding cloud of super simple atoms. So what happens next? Well, the next chapter is all about how that cosmic soup got cooked into the stars and planets we see today. It really all comes down to gravity. See, the early universe wasn't perfectly even. Some spots were just a tiny bit denser than others. And that little bit of extra mass meant a little bit more gravity. So stuff started to clump together. These clumps became the seeds for whole galaxies. And inside those young galaxies, enormous clouds of hydrogen gas, we call them nebulas, started collapsing in on themselves, getting hotter and denser until, poof, ignition, a star is born. Now, around these brand new stars, you've got all this leftover gas and dust swirling around in a big disk. And in that disk, little particles start sticking together. Then those clumps stick together, making bigger clumps. These are called planetesimals. Think of them like cosmic Lego bricks. Over millions of years, these planetesimals just kept smashing into each other and sticking together, getting bigger and bigger, until finally you have a few huge bodies that have cleared out all the other junk in their path. And those are planets. And that brings the story right here to our home. Because out of all those countless stars and planets forming all over the universe, we're going to zoom in on one in particular. Our own little rocky world, the early Earth. Yeah, you can forget that pretty blue and green marble you see in pictures from space. Early Earth was not a nice place. It was basically a hot, bubbling ball of molten rock with this really thin, pathetic little atmosphere of just hydrogen and helium. Definitely not somewhere you'd want to buy real estate. So how did we get from that to the planet we're on today? Well, a really important process called differentiation happened. Since the whole planet was basically liquid rock, the heavy stuff, like iron, sank right down to the middle because of gravity, and all the lighter, rockier stuff floated up to the surface. It's kind of like when you let salad dressing sit and the oil and vinegar separate into layers. And that's exactly how our planet got its structure. That sorting process created the layers we all learned about in school. You've got the super dense inner and outer core made of heavy metals, then the thick mantle, and finally, floating on top of it all, is the thin, light crust that we all live on. Okay, so we've got a planet with layers. That's a great start. But for life to get going, you need a couple more things. The next huge step was getting a real, stable atmosphere and, of course, water. This is pretty wild, but
Earth basically had two different atmospheres in its lifetime. That first one we mentioned, the one with hydrogen and helium, yeah, our young sun was so powerful that its solar winds just blew that one right off into space. So where did our current atmosphere come from? Well, it didn't come from out there. It came from deep inside the Earth itself. The process is called degassing. Just picture it. The young Earth is covered in volcanoes erupting constantly, and with every eruption, they're spewing out tons of gases that were trapped inside the planet. Gases like water vapor, carbon dioxide, and nitrogen. All of that volcanic activity literally built our second atmosphere from the ground up.
So let's put this on a timeline to see how it all fits together. As the Earth started to cool down, all that water vapor that the volcanoes had coughed up, it condensed, and it started to rain. And it rained and rained and rained for centuries, literally. That's what formed our oceans about 4 billion years ago. And it was down in those brand new oceans, about 3.8 billion years ago, that the next mind-blowing chapter of our story began.
So let's check our list. We have a planet with a solid structure. We have an atmosphere. We have oceans. All the ingredients are finally in place. All that's missing is the spark of life. The best idea we have right now is that life started as a really complex chemical reaction. Basically, non-living stuff somehow managed to arrange itself into molecules that could make copies of themselves. And boom, you have life. The first life was super simple, just microscopic organisms. But then, something happened that was a total game changer. One of these life forms evolved a new trick: photosynthesis, the ability to eat sunlight for breakfast. And you have to understand, this changed everything. For more than a billion years, these little tiny critters in the ocean were cranking out oxygen. To them, it was just waste gas, pollution. First, all that oxygen filled up the oceans. But then, about 2 billion years ago, we hit a tipping point. The oceans couldn't hold anymore. And so all that leftover oxygen started pouring out into the atmosphere, completely and forever changing our entire planet. And there you have it. What a journey, right? From a single tiny point to stardust forged into stars and planets, all the way to a living world that was so powerful, it literally changed its own air. It's an absolutely incredible story. It's an epic that's been unfolding for 13.7 billion years, which kind of leaves us with one last big question to think about, doesn't it? After everything that's happened to get us here, what's the next chapter in Earth's story?